talk about services, components, modules, layers. And why we need that is that we need to reason about that. And what we actually do is we have small number of large boxes rather than large number of small boxes. We abstract out a lot of code. But we actually lack a lot of common vocabulary. So if I ask you what do you mean by a term, something like component, for some people it can be a web app, which is a part of a larger system. And it can also be something which is running inside a web application. Yeah. Yeah. So another problem in communicating architecture is, do our architecture properly reflect the abstraction, and if it is coded, are there gaps or not? So we obviously talk in terms of services, modules, layers, but when it is getting coded, we obviously have, say, if we are talking about Java classes. So this is something which is called model code gap. Model can say something, code can say something, and there is actually a research to show. So if you ask developers to draw an architecture diagram, it will say something, and if you actually look at the code, most of the time you will find something else. And the reason for that is that we think in terms of components, but when it comes to writing code, we write in terms of classes that do layers. Yeah, so this is the good old architecture as we discussed. Layered architecture, we have presentation layer, business layer, data layer. And if we have to think about in terms of Java, obviously we have packages. So our layers are represented by the packages. In some sense it is horizontal slicing. But why we do this? One thing is obviously, as someone mentioned, there is separation of concern. There is substitutability there. We can write unit tested better. But there are other reasons associated with that. If you read books, you will find that this is how you should do it. And then you will find a lot of other explanations why you should do it. If you download code from internet, you will find that it is exactly how it is layered. So in terms of business layer, controller layer, and data layer. If you look at places like Stack Overflow, this is exactly how they ask you to have it modeled in terms of layers. Yeah, and that too in other languages as well. So Java, .NET, and all other languages.
Put it on this side.
Yeah. So if you can see that we have horizontal slicing here, and we have different feature sets A, B, C, and we draw. Then it looks really nice and clean. And if we have to think in terms of implementation in code, so all these will be different packages. But when you actually go and see the implementation that is coded by the coders, just because these are packages and we need to call them from different packages, these classes should be public. And since we allow that, there can be cases, so something like that, if I need some data from B feature set in my C controller, there are a lot of other ways which are actually possible, and since they are not restricted, people will use one of the other anyway. So that is regarding the layered architecture. Even if you have any hexagon or other Boolean kind of architecture, that stays true. So we can talk about this. Should layer be considered harmful? That will be very, very strong statement. So the better question to ask would be, is layering another cargo card. So do we do layering only because everyone else is doing it without knowing its effects? Or if layers are structure element, or we have a choice to have different structure and just put them in implementation. So there is this blog post by Uncle Bob, which says that if you look at all different architectures of different applications, you will basically see similar kind of architecture in terms of layers. But on the other hand, if you see a blueprint of house, you will know just by looking at if there is a house or a library or some other structure. And he says that this is wrong. So we are somehow trying to fit similar solution to every problem. Similarly, Martin Fowler talks about it, saying that we have layers, but as layers become bulky, there are chances that we are putting a lot of stuff in each of the layers, which can cause a lot of confusion. So the solution he proposes is not the horizontal slicing, but the vertical slicing based on the components as well. So this is an example of vertical slicing. Put everything in one package, feature set wise. And we also talk about that our abstractions or our architecture should represent the code. So let's go on that side. So there is another architecture pattern from Simon Brown, which is 4C model. What it basically talks about is that higher level we can have a, so this is C4 diagram. So if you know, so we start with context, we come to container, component, to classes. So think of container as something which is standalone, deployable, can run applications or can have data, and it internally is broken into, so there is a definition of container, and then it itself is broken into components, and each component itself is made up of classes. So it is much like a zoom in feature in, say, maps. So you can see a larger picture, and if you zoom in, you can look at specific internal details, and if you can zoom in further to go till your classes. So I'll quickly go through this. So this will be something like a context diagram. So you give just the context of it. On the top you see all the users. In between you see the application, and on bottom you see all the dependency. So this view gives you a rough idea of who possibly users are, how your system interacts with outside world. Then you zoom into your context, you see other components. So if you see in the diagram, there is a web application which is a single point of entry for all your users. And there is another component called content updater, which is a program which is getting data from Twitter, GitHub, and other blogs. And then you are storing data in the middle layer, which is relational database, file system, and NoSQL. So this is a zoom-in view of inside your system of the containers. And if you zoom in into your container, you will see components. So in this case, you see specific services which are running. So there is a scheduler operator which runs every 15 minutes and get data from all the connectors. And then there are components above which are feeding data into your data store. And so if you look at Twitter component, it's just getting data from Twitter and feeding into NoSQL MongoDB. If you zoom in further to your component, you will see class. But if you actually look at the implementation, if you implement it like normal layers, there will be two sets of classes in different package tool. So there will be a data layer, and then obviously one single layer. So what we have seen here is obviously we zoomed into our context, our containers and components, and when we reach the classes, we see something like this. And there is no one-to-one mapping, so they actually come from two different packages. So there is no single component here. So you can think about two solutions. Either we can go back to our diagrams and have two boxes for each component, or we can try to refactor this so that we can have just a single component, and which is so this is something we can solve by architecturally evident coding style. So what this architecturally evident coding style says that we obviously have in our architecture a lot of concepts which are not directly mapped into our languages. So even if we are talking about, say, something like component or module, I do not have a module construct or a component construct in my programming language like Java or any other language. So one way is to put custom annotations like add component. Another way which we can use is that we can have a naming convention that all services will have a service prefix, all components will have component prefix, or we can map them to a programming constraint, something like that a component will reside in a particular package and namespace. And obviously we have a lot of module frameworks which are coming up already there. And if you see architecturally evident coding style, it actually maps to our microservices as well, because microservices are built in a way that they reflect the architecture and they're very clean, separation of concern and all that. So from microservice perspective is good, but what about our monolithic system if we have to implement this? So one such solution would be, so package it by component. So we can use the already existing construct in programming languages, package. So the feature will get into a different package. Our component, both service and data layer, can get into another package. So if we apply this project to our existing code, so this is how it will get refactored. So we had two packages, a service layer and data layer, that will get refactored into single package, and we'll have a single interface which is exposed. Interface for DEO can go away. We can directly have the implementation. And the another thing which we can do here is, so earlier we had two public classes. So in the refactor code, there can be only one public class, so that it is bound that all my requests are coming through single class and DEO is not exposed directly. Yeah, and if you see code, it can look something like this. So there will be a single package having all the component classes, and we can have some custom annotations as well. So if we want to programmatically figure out our components. So now if you go and zoom into the Twitter component, you will see something like this, which is a single package and bundles everything related to that component. So what we are trying to do here, so we are actually trying to modularize our code. So why is this important? And then we also modularize the codes, but there are certain set of decisions which are still we can take. So if you ask something like this, where does your domain classes or shared code and utility go? So that is again a design decision we can take consciously. So for domain decisions, much like microservices, you can either put it in the domain itself, or you can have single back there and put your own domain classes. Again, if you have some sort of shared code which is used between multiple components, you can either choose to copy it between multiple components or keep it as a utility which is shared by your multiple components. So things like this will again come up as a design decisions for you. Again, coming about database, so one of the most difficult things you'll find converting a monolithic system into a microservice architecture-based system is that they are sharing data. So again, this comes up as a design decision. You can choose to have tables sharing foreign keys or tables without foreign keys. But these are all conscious decisions to take rather than arbitrary. And why is this important? So this gives you a lot of maintainability, because maintainability is inversely proportional to the number of public classes, dependencies, or microservices you have. Another benefit you get is agility. So we generally don't think about agility to start with. Because this is non-feature specification. So we should put agility along with scalability and reliability and other. And why is agility important is another thing, because nowadays our architecture itself depends on agility. So on one end we have monolithic architecture, which is a single deployable unit, very quick to code. But if you won't put constraint, so it can get really messy. On the other spectrum, you have service-based architecture or microservices, which is basically all different deployable unit, very minimal interaction or dependency on each other, and their individual deployable units and other benefits you get that you can code them in entirely different technologies as well. So if you see this component-based architecture will sit somewhere in the middle, that you have modules, but inside a monolithic setup. So this gives you a medium level of agility, and the other benefit it gives you if you want to transition into microservice-based architecture. So, tomorrow you can just carve out a particular functionality and put it as service. And if you look at nowadays, people are very much encouraged about microservice architecture because it gives you all sorts of features, much like individual deployable unit, individually you can upgrade them, individually it is replaceable, scalable, and as I told that you can use different technologies to code them as well. So these should be the real reasons you should go for microservices, not modularity. Because if you want to go for modularity in monolithic system, you can achieve it by coding them as component basis. So this is one of the takeaway that choose microservice only if you want for the real benefits which are these, not because your monolithic code basis. So the other thing is if you can align your software architecture with your code, obviously you get these kind of benefits. And one way to do that is this architecture identity coding style. This is all I have. So if there are any questions.
Yeah, you talked about the example of features in which you had 2 layers, and then the refactored one had one single component.
Yeah.
But in that case, how do we maintain both the different layers which we were talking about in the previous layer, as before?
Yes.
Versus in a single package, like there may be like one team is maintaining one package and the other team is maintaining another package, right?
So in this effect, after the code is refactored, a component resides in a package. So this goes in a single package. Earlier, obviously, your service layer and data layer were in different packages. So, and that's what it should be. That this is how it will look. So that is a single package. And all your package-related classes would go inside. So obviously, as you asked, you can say that layer architecture is gone. If you see that, I can say that inside my component there are layers, but they are not exposed outside. So for outside world, it is just a component. This is how outside world sees it.
It's like we are wrapping them up, provide a layer of abstraction.
Exactly. Yeah. So it is. We are thinking in terms of components. So the way we say we draw the architectural diagrams, we are putting them in code, and that by definition gives us modularity. Yeah.
So here we are seeing, we are taking the separation of person concept. Separation of person concept. In layered approach, traditional layer approach, database responsibility was for database layer, and the same layer is getting duplicated for each package. So there is a one more problem.
Yeah. So that's what I see.
We are introducing at some point.
Yeah, so if you ask me, okay, are we throwing away layer architecture? So as I said, that there are layers inside, and we are thinking more in terms of components. And so obviously, what you are saying is correct, but definitely should. So that those are design decisions as well. So if you really want data to be separate, or you want same data store, if you are using it. So generally, so you have to think in terms of component responsibility, single responsibility. So in this, so there was only one component which was talking and it's saving data to Twitter. So we can do that. But obviously, if there are more, then obviously we'll have to redefine responsibility itself.
Yeah. So somehow I'm seeing the benefit when we will be leveraging this with microservices or satellite architecture.
Yes. So this can be used as transition, and say the only problem is, so this somehow moves you in direction of microservices. So say obviously, so if you divide it on based on components, as I said, so tomorrow if you want to just have a single service, you can carve out that particular package itself, and then that package itself can be a single service. So you can actually copy a lot of code as well. So there's no major defect. Otherwise, you have to obviously do a lot of defect. And the other, it kind of forces you to think based on responsibility and component terms itself. So that is how exactly you think when you decide microservices. So that is the point I want to bring as well. So go to microservices for their real benefits. So if you really want individual scalability and different technologies, and if you just want say modularization, and if it is possible in monolithic setup, so this is gives you more agility. And so if this can fit your purpose, obviously you should do it. Because otherwise, if you think that, so people say monolithic is easy, so that's not the case. Just that you have structured your code in a way that does not restrict you to go from any layer to any layer, and so people exploit it knowingly or unknowingly in the code. So if you leave a chance for developer, obviously not everyone in the team will be experienced enough, so they will be interest running, they will misuse it anyway. So we don't want it. And yeah, then obviously there are benefits to think in terms of component as well, because if you draw an architecture, you can draw in terms of say starting from context, container, component, two classes, so everything will have. If you notate that the C4 is a static diagram, so this doesn't talk about how architecture will be deployed on say infrastructure. This is how exactly, so much like a zoom-in feature into your code from top level to bottom level, so it talks about functionality, overall functionality, how it interacts with the system, and components, and how components are arranged inside a container. So in that way, it's mainly static, and so you will have to again see what fits your use case. So on agility scale, it is somewhere between, it solves your problem.
Are we not using for diagram or a review forecasting?
Yeah, so that C4
any tool to design from say context to container to component.
we actually had a workshop to draw these C4 diagrams as well. So
That is intuitive. I mean, any tool where you have a navigatability.
Anand will probably know that.
Now there are tools to get class diagram, but above that you have to use
Thank you. So this is not UML. So some people compare UML as well. So there are other ways to depict architecture. But what they generally say that people generally don't understand UML correctly. So this is easy for everyone. Right?
C4 is very closely related to your code. So basically it gives you more than still UML has its uses of course. It's not, they are not replacing each other. They are complementary. C4 helps you understand current organization of code, how it is.
In this, the software architecture is slightly coupled with the code.
Yeah.
Yes, that's
So
what it is.
it should be loosely coupled, right? It should not be deeply coupled with the programming language.
Yeah, I was about to talk about
Programming
the
language.
one of the major reasons we go for layered architecture is I can have them hosted individually, I can use the load balancer, I can go for component load balance. When I package everything together, how can I achieve that? Apart from that, if everything is in one package, why are we
A component is in a package. So
why are we separating that? Only for modularity? That has to go for individual classes.
Yeah, so-
Inside the same library.
Platform.
Only one component will lie in a package. So we are mapping out, at least in this case, a component to a package. So if there are multiple components, they will go into.
So when we traditionally develop architecture for any enterprise application, you will have a lot of shared libraries.
Yeah.
And you will have a lot of objects which can be shared. It could be single-memory objects, it could be database objects, or it could be some shared libraries. Now, traditional architecture, what it does is, I call it a component architecture. When you component them, you divide them in such a way that you can reuse them, and you can deploy. If you deploy it one time, it is available for everyone. Whereas in this case, if I don't architect that, will I not be using the reusability of it?
This is exactly the same.
You actually, I think your answer was in your question itself. You said that we deploy layers separately, so we make layers so that we can deploy them separately. We don't. We deploy components. Components are made of layers, right? You don't put a server where only data access layer is there, another server where only business layer is there, right? You put components, you put services.
Okay, I think we are assuming layers are only business layers.
No, he's only, that's what his talk is that, again is that, don't make layers at code level. If you are exposing a component, like you just now said, that I want to deploy this component separately, think of that whole component as one. Don't make layers within them which are publicly exposed.
That's right. So then what's the point in making this
You still have layer within your component. So it is, microservices. We are taking the same microservices approach, we're taking it down to component. So that every component has everything it needs within its.
That's right. So, initially, problem that we stated is developers are not disciplined enough to use the classes on the so here you are just narrowing down their choice, but that can still happen.
We are taking this architecture. Yeah.
This architecture separate.
See, in architecture there was no layer. There were boxes. Each box represented a component. But if you look at code, your box, which was one box in the diagram, in code it is represented in 3 layers. There is a data access layer, which lets a customer component. There is a data access layer for dealing with that. There is a business layer which is dealing with that. So you have different classes at different layers dealing with the same concept. Now we are saying is, take all of them, put them together, only expose the concept, do not expose the original details.
So, package here, like it brings this logical thing of things.
So we are saying package them in components, don't package them in layers.
So the book package or the GitHub package will be directly calling module the Twitter DAO is only via the components.
So all the code that calls MongoDB tweet DAO, that's my data access class, all the code that needs that, put them together. So you have your business layer there. Basically, don't expose your data access layer, don't expose your lower layers, expose the component. It's exactly same as microservices. Microservices, we say the same, right? Expose service so that you can deploy them separately. And sometimes you might have duplication within them. We are okay to live with it because currently in the scalable world, we never have shared memory, we never work with shared memory or static objects because you can have thousands of servers running. Everything has to be independently executed.
The real motivation, right, is I'm talking about microservices, right? So the point is the components or layers that represent a component or a set of components should actually be deployed as a service in a separate VM or a separate container. And the other thing is typically, these are managed by different teams that are probably part of different business units. And they have their own development cycles independent of other teams. So that gives them actually much more agility. So microservices is along with the architecture strategy, needs more in terms of a driver for agility. The next agility for the business. So it could be product development, it could be line of business, an enterprise, it could be, you are actually having separate teams owning stuff separately. So that is very important. And this kind of helps you achieve that because you don't have those horizontal, data access DLL or package that is owned by one horizontal team that doesn't give you agility. More than a design pattern, it is a problem of agility.
Any component can make a call to any data.
No, that structure it won't just be agile enough. It will actually become a bottleneck. And you'll get into what is usually called DLL hell in Windows, right? You will get DLL hell if you kind of don't use these patterns.
Okay. Thanks.